Good morning, everybody. Thanks for being here, and also thanks to the organizers for putting together such a great conference. I really appreciate the opportunity to speak here today. My name is Adrian Vollmer, and I work for the German pentest company Seth. We get paid to hack other companies, and today I want to show you how to hack the remote desktop protocol. RDP is used, I think most of you know what it is, but it's used to control Windows machines remotely, and especially in corporate environments. And every time I do a pen test in an internal network, and I eventually gain the ability to log into the domain controller as a domain admin with RDP, I notice that in, say, 95% of all cases, I see a warning like this. So this is a certificate warning. It says it cannot verify the server's identity because self-signed certificates are used. Just as a reminder, every certificate contains a public key, and if the certificate was signed with the corresponding private key, we call it a self-signed certificate. Everybody can create their own self-signed certificates, which is why it provides almost no protection against man-in-the-middle attacks. That's why we always recommend to use properly signed certificates. But for me, it's not enough to just tell my client that he can be man-in-the-middle if he's using these certificates. I want to show him. And for that, we used to use a tool called Kane. You actually just saw it in the previous talk for cracking the passwords. Kane can do a lot of things. It can also perform ARP cache poisoning to gain a man-in-the-middle position and sniff interesting things like credentials and RDP connections. And it's my opinion that the author of Kane is highly talented, and Kane is a great tool, but there's a couple of downsides to it. First of all, it's only for Windows. Second of all, it's closed source. It's really old. It's not supported anymore, and it can only attack the lowest security protocol of RDP. As a result, the victim doesn't really see a certificate warning. It sees a slightly different warning instead, and it doesn't get prompted for the credentials in a Windows form, but instead gets forwarded to the Windows logon screen on the RDP host. And that always bothered me when I tell the client, you cannot detect a man-in-the-middle attack, and then I show him, and then it does look slightly different. It always bothered me that it doesn't look exactly the same up to the fingerprint of the SSL certificate. That's why I decided to write my own tool. It's called Seth. It's written in Python, it's for Linux, it's open source, and it's also a little bit more sophisticated. And it's intended to be used in pen tests or workshops to sensitize IT admins or managers regarding the risk that self-signed certificates bring. Make no mistake, this is not a new vulnerability or anything. This is merely the exploitation of a misconfiguration. And at first I thought, how hard can it be? It's SSL, just use an SSL proxy. But it wasn't that easy because RDP is using something similar to star TLS, which is also used in emails or FTP, where in the beginning, during the protocol negotiation phase, it speaks clear text, and afterwards it switches to SSL. So you need a proxy that is aware of the protocol and knows when to perform the SSL handshake. So while RDP may be a proprietary protocol, the specifications are publicly available, so I read them and I went down the rabbit hole. But first let's look at a typical RDP connection in Wireshark. So here you can see every single TCP packet, and the first three packets represent the TCP handshake. And in the fourth packet you can see the first message from the client to the server where it announces its capabilities. So down here you can see the client is capable of TLS security, or also called enhanced RDP security, and it is not capable of CRED at SSP, which is also known as NLA, network level authentication, and it's also not capable of early user authorization. The latter is a feature where the server checks whether the user is authorized to log onto the server before the authentication happens. And then in the next message, the server answers with its choice of security protocol, usually the highest one that both parties are capable of, and then the SSL handshake happens. That we can see if we tell Wireshark to decode the stream as SSL. Then you can see the client hello, the server hello, the certificate, and so on. And then you don't see anything anymore because the connection is now encrypted. All right, so if we want to attack RDP, we need to know everything about these security protocols. And in RDP, there's 3 of them. There's standard or native or plain RDP security, which is baked into RDP itself, so every client needs to be able to speak it. There's also enhanced RDP security, which is essentially just SSL. And there's network level authentication. And here we need to distinguish between Kerberos, which can be used in a domain, or in any other case, net NTLM v2, or in short, I'll call it NTLM. But it's not to be mistaken for the NTLM hash. All right, first, standard RDP security. It's similar to SSL, but it's not SSL. It's similar in the sense that there's an asymmetric cipher that is used to exchange keying material that is then used for a symmetric cipher to encrypt the rest of the session. And in this case, these ciphers are RSA and RC4. So it works like this. The server sends its certificate to the client, which is signed by the private part of the terminal service assigning key. The client then takes the public part of the terminal service assigning key to verify that the certificate is legitimate. And if that's successful, it uses the public key of the server certificate to encrypt the random value and sends that to the server. Then the key exchange is done, and the rest of the session is encrypted with RC4. So, as an attacker, you'd be very interested in having that private part of the terminal service assigning key, because then you could just create your own certificates, make them look legitimate, and the client couldn't tell the difference. So it kind of seems like a big deal, and the question is, how would you go about obtaining that private part of the terminal service assigning key? It must be really difficult, right? Well, not really. You just go on Microsoft.com, and as you can see here, you can just download it. The reason is, I said the terminal service assigning key on purpose because there's only one. It's the same in every single Windows instance, and with a little effort, anybody can extract it. And when that became public knowledge, Microsoft just went ahead and decided to publish it themselves. And they now recommend not using standard RDP security at all. And I agree, it's broken. It's essentially clear text. Breaking it is simply a finger exercise, which I did. And that's also what Kane is exploiting. But since it's not really used these days anymore, I don't want to go into any more details on that. The next protocol is enhanced RDP security. That's proper SSL. So the responsibility of verifying the certificate is shifted to the SSL stack of the operating system, which then should have the appropriate root certificate stored in the certificate store. And then the credentials are simply transmitted inside the SSL tunnel. And in this case, if the domain controller does not have the role active directory certificate services, self-signed certificates are used by default. And that's what makes this protocol vulnerable to man-in-the-middle attacks, because the victim does see the warning but can't really determine if the self-signed certificate is the correct one or not, if it belongs to the server or a man-in-the-middle. And finally, the last security protocol, it's NLA. First, NTLM. In this case, they also use SSL, but instead of just transmitting the credentials, there's a challenge response method that is being used. So the server sends a random value, the server random, to the client. The client takes this value along with some other information, such as another client random, a server name, a timestamp, and everything, and takes the hash value of all of that. And also, most importantly, the hashed user password. The result of that is called the NTLM response and sends it back to the server. And by the way, since we only need the hashed user password and not the user password itself, is the reason why things like pass-the-hash attacks work. The server receives the NTLM response and then does the same operation. If it's a local user, it gets the hashed user password of the local database, and if it's a domain user, it asks the domain controller to do the operation for it. The hash value that is transmitted here, so the NTLM response, cannot be used for replay attacks or pass-the-hash attacks because the server random effectively acts as a salt, so it cannot be reused. But the method is vulnerable to offline cracking attempts. If you have the NTLM response, you can try to guess the password that the user has. And you can also exploit this for relay attacks on SMB services. Well, if the user, the client, and the server are managed by a domain, we can use Kerberos. In Kerberos, the client requests a ticket with the Kerberos servers, and then presents this ticket to the RDP host, and the host can verify the ticket without having to contact the domain controller. This is an example of secret key cryptography as opposed to public key cryptography, where the hashed user passwords are the shared secret, and the domain controller or the Kerberos service is a trustworthy third instance. So Kerberos also has several vulnerabilities. I just want to mention Golden Ticket or Kerberos, but none of that are relevant if you want to attack RDP. So this is the best security protocol that you can use in this context. And now we already have everything we need to know to construct our attack. I'm assuming that our starting point is already a man-in-the-middle position. For example, you can do this by ARP cache poisoning. There's also other ways to get in the middle, but if you just want to use this as a quick proof of concept, this is perfect. And the goal is to downgrade an RDP connection from Kerberos to enhanced RDP security. Step 1. The client wants to do Kerberos authentication. We want to prevent it. How could we do it? Remember when I said that the client requests a ticket with the domain controller? Well, let's just block all TCP traffic on port 88. Then the client won't be able to get a ticket anymore, but still wants to connect. And at least the implementation by the Microsoft client will then simply fall back to NTLM. The next step is then to redirect the traffic through our Python proxy. Then we can observe and modify the information that's being exchanged. This is pretty straightforward. You just use some IP tables rules, and that's that. In step 3, we want to prevent NTLM authentication, because now the client wants to do NTLM. But this is a little bit more difficult. We can control the traffic that's flowing between the client and the RDP host, but not the traffic between the RDP host and the domain controller. Or else we could maybe try blocking the communications to the domain controller as well, since the RDP host will want to do that to verify the NTLM response. But the question I asked myself, what does happen if the RDP host can't reach the domain controller? So I played around with the DNS settings on the RDP host, and the answer is that the host says this. Unfortunately, computers don't speak English, and I'm not exactly fluent in computer speak either, so I can't really tell you what this means. I couldn't find it in the specifications, but I assume it means something like, I couldn't reach the domain controller. It doesn't really matter anyway, because we'll just use it, and we'll replace the message that the RDP host sends to the client after receiving the NTLM response with that, and make the client believe that the RDP host couldn't reach the domain controller. That's already all we need. Because at least the Microsoft implementation will then still want to connect, and well, if it thinks the host couldn't reach the domain controller to verify the NTLM response, it will just fall back to enhanced RDP security, which is what we wanted. And at this point, the victim will be presented with the certificate warning, and if they're not careful enough with checking the fingerprint, we'll just wait for the victim to ignore the certificate warning, lean back, read the clear text credentials on our connection, and well, we can also read keyboard events. We can see what the victim is typing in the RDP connection. Let me show you a live demo. Actually, it's not a live demo, it's a video to make sure everything works correctly. On the left-hand side, you see a regular Windows 10 client trying to connect to the domain controller. On the right-hand side, you see a regular Kali Linux which is running our script. So we specify a couple of IP addresses, and now did I say we can read keyboard events, and we can go, there's nothing really preventing us from also injecting keyboard events here. So you know the hotkey Windows R, and you can execute commands. We can abuse this to execute our own commands, so we have immediate command execution as well. Let me just show you this with the Windows calculator. All right, so the victim's connecting. On the right-hand side, there's all kinds of things happening. I'm actually cloning the original X509 certificate, which means I'm parsing the ASN1 structure and replacing only the public key with my own public key. And then I'm re-signing that certificate with the corresponding private key. Everything else is exactly the same. The serial number, expiration dates, everything. The whole certificate looks exactly the same except for the public key, the signature, and of course then the fingerprint, which is also all not very human readable. Here you can see the certificate. This is already the bogus certificate. On the right-hand side, you can see the NTLM response. You can already feed this into John the Ripper or whatever and try to guess the password. And if the client clicks OK, you can see the password on the right-hand side. And then we're injecting the key presses, and you can see calculator was executed. And of course, you can see what the victim is typing. I cheated a little bit here because I disabled mandatory NLA. And if you're now maybe thinking, well, on our network, we got mandatory NLA enabled everywhere, so we're safe, then think again. Let me show you. I'm enabling mandatory NLA and do the whole thing again. And the problem with it is that NLA is a server-side configuration, so it only protects the server. But this is an attack on the client, so it can't really help you at all. Except that when we downgrade the connection to enhanced RDP security, the client will not want to do that. But that's fine, we just stop talking to the client altogether and just keep, to the server altogether, and just keep talking to the client up until authentication. And that's already all we need, because then we'll still get the clear text password. Unfortunately, then the client will notice that the connection will be lost, but we already got what we wanted. You can see on the right-hand side, the script is switching to a fake server mode or honeypot mode since it stopped speaking to the server. And there you have it. You have the password on the right-hand side. Connection is lost for the victim, but at this point we could still re-establish a connection to the original host using NTLM, because we already have the clear text password. Then we would need to speak enhanced RDP security to the client and NTLM to the server, and the client wouldn't still notice it. It's just a little bit difficult because you have to go up one layer, and seems to be too much work for me, so I haven't done it. Okay, if you want to play with it yourself, if you want to read the code, try it out. You can go on our GitHub. I also put a paper there where I go into great detail about the attack, so if you want to understand everything down to the last bit, I recommend you check that out. And of course, pull requests are also welcome if you want to take part. All right, so what can you do about it? As we've seen, NLA is largely useless in this case. It only protects the server, and it protects the server from two things. It protects it from maybe a 0-day in the RDP itself, or in, I don't know, the Windows logon screen. And it also saves you a little bit of resources, because you need valid credentials to establish a connection. Without NLA, you could establish a connection, you would see the Windows logon screen. So that uses up a little bit more resources. So if denial of service is a concern to you, you may want to enable mandatory NLA. But it could even be counterproductive. I don't know who has seen the talk yesterday by Sultan. He was also mentioning this piece of best practice where domain admins should only log into the domain controller, or else they will leave traces on workstations which could be exploited by attackers. You can use Mimikatz to read hashes and passwords and all that. And that's what's happening if you use NLA, because then the credentials, as we've seen, are kept on the client in memory. So it kind of defeats the purpose of using domain admin accounts only on the domain controller. And SSL is already secure. We already all use it to do our online banking or to check our emails. It's just that we can't trust every single certificate that we encounter. So what you should do is you should configure your clients that they must not establish connections to an RDP host if they cannot verify its identity. For Windows machines in a domain, there's a GPO for that I put here. Other clients, of course, you need to configure separately. But this is really the only way to ensure that you can be attacked by this. Of course, this requires setting up a public key infrastructure. You need to roll out properly signed certificates, either signed by your corporate CA, or you can also buy certificates by someone else. That's actually the official recommendation by Microsoft. So I'm nearing the end of my talk. I'm sure you want to get coffee. And the message I want I want you to take home today is, if you're a pen tester, please go ahead, try out Seth. Let me know how it works on your engagements. And if you're an IT admin or IT manager, please don't use self-signed certificates, and educate your users and your coworkers to take certificates warning seriously. Thanks for your attention.